Okay, so you probably saw the headlines back in January. Starship explodes at 418 kilometers. Debris raining down over the Caribbean. 3 passenger planes nearby with 450 people on board. And the internet went absolutely nuts. The Wall Street Journal ran this whole piece basically saying SpaceX got lucky. That passengers were gambling with their lives. That this was way more dangerous than anyone admitted. But here's the thing. When I actually dug into what happened that day, I found something completely different. Something that actually makes me more confident about Starship's future, not less. So let me walk you through what really went down on Flight 7. Because this story, it's not about luck at all. January 16th was supposed to be a good day. Flight 7. First time flying the upgraded B-2 design. Booster 14, Ship 33. And honestly, the booster side went perfect, like textbook, Mechazilla catch. Clean, precise, beautiful. But Ship 33? That's where things went sideways. During ascent, something weird started happening. A harmonic reaction. Think of it like when you hit just the right frequency and a wine glass starts vibrating. Except this is a massive rocket, and that vibration got worse and worse. Fuel started leaking, oxygen too, pressure building up faster than the vents could handle. And when it hit critical levels, the flight termination system kicked in. Boom! Vehicle destroyed, at 418 kilometers up. Now debris is scattering across the Caribbean sky. People on the ground are filming these streaks of light. It looks like shooting stars, except everyone knows it's not. It's pieces of a $3 billion rocket breaking up in real time. And here's where it gets interesting. 3 commercial flights were operating in that general area. JetBlue from Boston to Puerto Rico. An Iberia flight. A private jet. About 450 passengers total. So what happened to them? 0 injuries, 0 emergency landings, 0, oh crap, we need to divert now moments. All 3 planes landed normally. Passengers didn't even know anything happened until they checked their phones later. How is that possible? This is the part that blew my mind when I really understood it. SpaceX doesn't just launch a rocket and hope for the best. They've built this 3-layer safety system that kicks in before the rocket even leaves the pad. And on January 16th, we got to see it work under the absolute worst conditions possible. Weeks before launch, SpaceX sits down with the U.S. Space Force and maps out these massive hazard zones. And I mean massive. These aren't small areas. They're huge 3D volumes calculated to contain debris from every nightmare scenario you can imagine. What if the rocket breaks up at max Q? Covered. What if an engine fails? Covered. What if the flight termination triggers at 400 kilometers? Also covered. Engineers run thousands of simulations. They calculate where every piece could possibly go, factor in atmospheric drag, Earth's rotation, all of it. Then they add safety margins on top of that. For Flight 7, this zone covered a huge chunk of the Caribbean and Gulf of Mexico, not because they expected debris to spread that far, but because they needed to account for the 99.9999% worst case. Now you might be thinking, okay, but doesn't that mess up a ton of flights? Yes and no. The FAA doesn't just close the whole zone and shut down all air traffic. They work it into the system ahead of time. Airlines get NOTAMs, basically official warnings, that say, hey, there's launch activity in this region during this time window. Flight planners route around it. They adjust departure times. They factor it into fuel loads. This happens for every launch, not just SpaceX. United Launch Alliance, Rocket Lab, everyone does this. It's routine. But what about when things go wrong? The moment Ship 33's flight termination system triggered, several things happened at once. The FAA's air traffic control system got pinged immediately. Controllers could see in real time where debris was actually falling, not where it might fall, where it was falling, and they had the tools and authority to actively route those 3 aircraft around the actual debris field. This is the part the Wall Street Journal completely missed. Those planes weren't forced through contaminated airspace. They were actively guided around the zones where debris was contained. Controllers had live data, established protocols, and clear authority to keep everyone safe. Every single trackable fragment stayed inside the pre-coordinated boundaries. The system worked exactly as designed. Think about what that means. SpaceX basically said, "We're going to plan for this rocket to explode at the worst possible moment, and we're going to make sure even that scenario keeps everyone safe." And that's exactly what happened. When SpaceX responded to that Wall Street Journal article, they were pissed. You could tell. They called out the complete lack of understanding of the robust tools used by safety officials. That's engineer speak for, "You have no idea what you're talking about." Because here's the thing, these safety protocols aren't new. They've been refined over 70 years of rocket launches. Apollo used them. Shuttle used them. They're based on orbital mechanics, atmospheric physics, materials science, real math, real physics. When SpaceX says their hazard zones are science-based, they mean you can literally verify the calculations yourself if you have the engineering background. The FAA reviews them, Space Force reviews them, NASA reviews them. Multiple layers of verification before any launch gets approved. But the Wall Street Journal article? It relied on anonymous sources interpreting FAA documents without that technical context. And look, I get it. Investigative journalism is important. Anonymous sources can reveal real problems, but there's a difference between a whistleblower exposing actual safety data and someone interpreting complex aerospace operations without understanding how they work. The FAA did a full investigation after Flight 7. They had telemetry data, radar tracking, debris analysis, timeline reconstruction. They interviewed controllers, reviewed communications, examined flight recorder data. Their conclusion: no public injuries. All flights safe. Protocols worked as designed. So when an article comes out a year later saying there was greater danger than publicly known, based on anonymous interpretations, what new evidence is there? The article doesn't claim new debris was found where it shouldn't be. It doesn't identify any aircraft that encountered fragments. It doesn't contradict the FAA's investigation. It just reframes the same incident to sound scarier. You know what's funny? We've been through this exact same cycle with Falcon 9. Back in the early 2000s, critics said the same stuff. Too experimental, too ambitious, moving too fast. Every anomaly generated headlines about how SpaceX was reckless and endangering public safety. Fast forward to today. Falcon 9 has over 380 consecutive successful missions. It launches more than every other orbital rocket combined. 96 flights in 2023 alone. And despite that insane cadence, it rarely disrupts commercial aviation or generates safety incidents. How did that happen? Through the exact same iterative process SpaceX is using with Starship right now. Early Falcon 9 flights had failures: a first-stage explosion in 2015, a pad anomaly in 2016, a second-stage issue in 2023. Each one triggered investigations and criticism, but each failure also provided data. SpaceX learned, adapted, fixed root causes, and over time, Falcon 9 became the most reliable rocket flying. Starship is following the same path. Flight 7 revealed a harmonic reaction issue they didn't catch in ground testing. They analyzed it, identified the cause, modified the design. Flights 8 through 13 in 2025 incorporated those changes. The trend line is clear. Reliability is increasing. And here's something people forget. SpaceX has every incentive to prioritize safety. A single incident causing public harm wouldn't just be bad press. It could shut down operations entirely. Kill the Starship program, end Starlink expansion, cancel Artemis contracts. Their entire business model depends on Starship achieving reliable, high-cadence operations. You can't build a sustainable space transportation system if your safety protocols suck. Looking ahead to 2026, SpaceX has big plans, dozens of Starship flights per year, orbital refueling, lunar cargo missions, eventually crew operations. Every single one of those milestones requires FAA approval based on demonstrated safety. They won't approve crew flights until Starship shows the same statistical reliability that qualified Falcon 9 and Dragon for NASA astronauts. That's years away, and SpaceX knows it. But the foundation is being built right now, through developmental testing like Flight 7. So here's what Flight 7 really proved. SpaceX didn't get lucky. Their safety system worked exactly as designed. While the Wall Street Journal saw danger, aerospace engineers saw validation under the ultimate stress test. The brilliant part? The solution wasn't built after the problem happened. It was designed before the first launch. That's the difference between speculation and actual engineering. Now, I want to hear from you. Does understanding how this system actually works change your perspective on Starship's safety? Drop your thoughts in the comments. And if you want more technical deep dives that go beyond the headlines, hit that subscribe button. We've got a lot more coming. Thanks for watching. Keep looking up.